Alright. I'm going to go rather quickly through the three diagrams. Okay, it's not something that they ask that often. So I explained to you guys yesterday that when there's a raffle and you can win prizes if you bought the tickets and you can win the different prizes. There were three prizes. Those three prizes, the draws for those three prizes will be the three events. Okay. And the outcome of each event is you can either win or you can lose. Okay. So, for the first draw, you can win or you can lose. Do you agree with me? For prize number 1. You have 8 tickets in there. So the chance of winning is 8 over 250. The chance of not winning is 242 over 250. Does that make sense? Okay. If you won the first prize and then take the second draw, you can still win the second prize. You can either win it or you can lose it. Because they drew your ticket, you won that first prize, né? So one of your tickets has been taken out. There will be 7 of your tickets left. And there will be 249 tickets in the bag because one was taken out and the one that was taken out had your name on it. So there's only 7 left with your name over the 249 and there are 242 that don't have your name on it. Do you all understand that? If you won the first prize and you won the second prize as well, how many tickets will be left with your name on for the third prize? 6 over 248. Because 2 tickets has already been taken out, both those tickets had your name on it. So you started with 8, now left with 6. The chance of not winning, of losing, is going to be 242 over 248. Okay, if you won and you lost, there are 7 tickets left that you can win. And 241 that you can't win. If you lost, all 8 of your tickets are still in there. And there are 249. 241 over 249 is the chances of you not winning. If you lost and you won, there are 7 tickets left for you to win again and 241 for you not to win. If you lost and you lost, then all 8 of your tickets are still in there. 8 of the 248 is win, 240 over 248 is lose. Do you understand that? Must I redraw it for you? And do it with you? Okay. Let me redraw it. There are 250 tickets. 8 of them is a winning ticket for you. It's got your name on it. So when they make the draw for the first prize, there are only 2 outcomes. You can either win or you can lose. Yes, we know the chances of you losing is much higher, né? But it's still just 2 outcomes. The chances are different, but there's 2 outcomes. You can win or you can lose. How many of those tickets that they can draw has got your name on it? 8. How many tickets are there in total? How many tickets does not have your name on it? 242 over 250. Okay, that's for the first prize. If you won the first prize and they take the draw for the second prize, What are the two things that can happen? You can win the second prize or you can lose the second prize. If you lost the first prize, what can happen with the second prize? You can win the second prize or you can lose the second prize. Okay. Let's fill in these fractions first. If you won the first one, how many tickets are in there for you to win the second one? 7. How many tickets are there in total? 249. So how many does not have your name on? All you actually have to do is you take the total and you subtract that. Do you see that? Because it has to give you most 1. Eh? So you can just say 242 over 249. Do you understand? If you lost the first prize, how many of your tickets are in there? 8. But now there are only 249 tickets left. How many does not have your name on it? 241 over 249. Happy? Okay. Now it's the draw for the third prize. If you won the first prize and you won the second prize, what can happen in the third prize? You can still win or lose. If you won and you lost, then you can still win or lose. If you lost and you won, you can win or lose. If you lost and you lost, you can still win or lose. If you won prize number 1 and you won prize number 2, how many of your tickets are left in there? How many tickets are in the bowl? 248. Okay, how many does not have your name on? 242 over 248. If you won, you had 8, ne? You won, so now you have 7. Now you lost. So how many are left there for the next one? 7 out of 248. And all of these denominators are the same. All of these denominators are the same. Okay, if you won and you lost, how many chances are left for you to lose again? So how many does not have your name on it? 241 over 248. I just did the subtraction for the second leg. If you lost and you won, you started with 8, you lost, but then you won. How many of your tickets are left? 7 over 248. And here, 241 over 248. If you lost and you lost, you had 8 tickets to start with. You lost both. How many of your tickets are still in there? 8. Why would it be 6? And then how many does not have your name on it? 240 over 248. Happy? Okay. Do you understand it better now? I'm not going to pay that much attention to the answering the probabilities. Is that okay? Because now the first question they ask, what's the probability of not winning a prize? You would say 242 over 250 times 241 over 249 times 240 over 248. You understand that, ne? Okay. The probability that he wins one prize. Then you're just going to have to check. There he wins, loses, loses. So that one is a branch where he only wins once. Loses, win, lose. There's a branch with only one win in. Lose, lose, win. There's another branch with only one win in. You do their multiplication and then you add the 3 answers. Okay. The probability that he wins 3 prizes, 8 over 250 times 7 over 250 times 6 over 249 times 6 over 248. Just multiply the fractions. And if there are more than one outcomes that you want to choose, you add those outcomes. Okay, can we go on? Next one is going to be number 3. They have 3 white marbles, 4 blue marbles, and 3 red marbles. Okay, the event is happening simultaneously. So I told you guys, when you draw a tree diagram for that, simultaneous means your tree diagram will look exactly the same. All you have to remember is that it's dependent. Okay. So when I put in my hand into that bag of marbles, how many different outcomes are there? 3. I can get a white marble, a blue marble, or a red marble. Okay. So it's 1, 2, 3. White, blue, red. If I take the other hand, whether I'm seeing it as happening right after each other or simultaneously, what are the outcomes for my other hand? White, blue, red. White, blue, red. White, blue, red. Do you all understand that? Okay, and it was just 2 events. So, how many marbles are in there in total? 10. What's the odds of getting a white one? 3 over 10, 4 over 10, 3 over 10. If I got a white one in the one hand, how many white ones are left for the other hand? 2 over 9. How many blue ones are left if I took a white one? 4 over 9. How many red ones are left? 3 over 9. And you can check, that will give you 1. If I took a blue one, how many white ones will be left? How many blue ones? How many red ones? Good. If I took a red one, how many white ones? How many blue ones? How many red ones? And that's it. Okay. Now they can ask the questions. What's the probability that both will be white? You're going to say 3 over 10 times 2 over 9. That gives me 6 over 90, which is, what over 15? 1 over 15. What's the probability that both marbles will be the same color? So I've got the white and white probability. The blue and the blue probability will be 4 over 10 times 3 over 9. That gives me 12 over 90, which is 2 over 15. And then red and red is also 3 over 10 times 2 over 9. That's also 1 over 15. So these are 3 different outcomes that I want to add to each other. So the probability for 2 of the same colors will be a 15th plus 2 15th plus 1 15th. That gives me 4 over 15. Do you all understand? Did someone say no? Okay, now the next one, I just want you to focus when I talk about the next one, because this is important to me. If they're now asking you, what's the probability that both marbles will be different colors? Now, we just calculated the probability if the marbles are the same colors. Now, all of the other outcomes will be 2 different colors. It will be white and blue, white and red, blue and white, blue and red, red and white, red and blue. So you can do this in 2 ways. Either you can calculate that line, that line, that line, that line, that line, that line, add all of them. Or you can just say 1 minus 4 over 15, and then your answer will be 11 over 15. Do you understand why I did that? This is the probability of getting the same color. This is the probability of not the same color. Happy? Agricole. Okay, we've got 4 sandwiches and 3 bananas. Nee. Okay. When I put my hand into the kosblikkie, how many different outcomes can I get? 2. I can get a sandwich or a broodjie, or a pisang. What was this? A pisang. Banana. And then he puts his hand again, he gets a sandwich and a banana. And then he takes a third one. No, there was a third one as well. Sandwich and banana, sandwich and banana, sandwich and banana, sandwich and banana. Okay, what's the odds of getting a sandwich? Banana. If I took a sandwich the first time, what's the probability for sandwich again? Banana. If I took a banana first, what's the probability for sandwich? Probability for banana. If I took a sandwich and then I took a sandwich again, what's the probability for a sandwich in the last one? Probability for banana. If I took a sandwich and then I took a banana, what's the probability for a sandwich? Probability for a banana. If I took a banana and then I took a sandwich, what's the probability for a sandwich? Banana. If I took a banana and I took a banana, how many sandwiches are left? How many bananas? Yeah. So you got the 3 diagrams, right? Now it's easy. The questions about it, the probability that he will get a banana and then a sandwich and then another sandwich. So it's banana, sandwich, sandwich. It's going to be 3/7 times 4/6 times 3/5. That gives me an answer of 6/35. Happy? The probability of getting 3 bananas, it's 3/7 times 2/6 times 1/5. The answer is 1/35. The probability that he will get 2 bananas after he took out the 3 things. So they don't care about the order. He just wants 2 bananas. Okay. So it's sandwich, banana, banana. This one plus banana, sandwich, banana. That one plus banana, banana, sandwich. So you're just going to multiply the 3 of them and add them. I'm not going to do that now. Are you good? Okay. Venn diagrams. Okay. Now, luckily, we already spoke about Venn diagrams. So, I think if I were to give you this example, you would actually know how to draw it. But wait, before we do the example, I want to do something else with you. Just want to interrupt myself there quickly. Okay. We're going to look at these 2 Venn diagrams. I'm going to ask you what's the probability or what's the numbers, and then you're going to tell me the answer. So just tell me what type of event is this? Inclusive. And this one? Mutually exclusive. And there's something else about him? He's exhaustive. There's no number on the outside. You remember that? Okay, this one is not exhaustive because there's a 1 on the outside. Okay, these are not the number of values. This is just the numbers we have in there is 1, 2, 3, 4, 5, and 6. And this one is 7, 8, 9, 10, and 11. Do you understand? Okay. What's the probability of getting A? What's the probability of getting A? Come, you guys need to work with me, otherwise we're not going to finish. No one's going to laugh if you get it wrong. Just try. Remember, this has nothing to do with that one. This is a Venn diagram for A and B. This is a Venn diagram for C and D. Nee, askies, sorry, ons rekord vir die klas. Dankie. This one has got nothing to do with this one. So what's the probability of getting A? How many values are there in A? 1, 2, 3. So the probability to get A is 3/6 because it's in A's circle. Okay. What's the probability of getting B? 4/6 because there are 1, 2, 3, 4 numbers. There are 6 numbers in total. What's the probability of not getting A? Not getting A. You can get anyone, but not A. Why do you say 3, Moana? Which numbers are the numbers? 3, 5, and 1. Ek record nie. 3 out of 6. Because all of the other numbers are inside of a circle. You get that? Okay. What's the probability of getting not B? 1, 2. That's not part of B. Okay. Which are the numbers for A or B? Which numbers? So I'm not asking for a probability. I'm asking which numbers are A or B. Or. You are telling me what is and. And is that one. Who has maths or accounting? 2, 4, 6, 3, and 5. Either the one or the other one or both. They must just have an A or a B. Do you understand? So the numbers for A or B is 2, 3, 4, 5, 6. Okay, I don't want to page, so I took a picture of the questions. Just want to get it, yeah? Okay, what's the probability? You now told me what's the numbers of A or B, ne? What's the probability of getting A or B? What's the probability? Always a fraction, eh? So what's the probability of getting A or B? 5/6. What's the probability of getting A and B? 2/6. What's the probability of getting not A or B? 1/6. There, you're getting the hang of it. Good job. What's the probability of getting not A and B? 4/6. 1, 2, 3, 4. Because that's and. So they want the probability of getting not and. Okay. What's the probability of getting A and not B? Okay, so and, if we have the word and, it must be true for both of the things I'm saying. Okay, so if I say probability of A and B, it must be true for A and it must be true for B. That's why it was the part in between. When I say or, A or B, it must be just it must just have one of the two parts. Does that make sense? Now, I'm asking for the probability of A and not B. Which one numbers would that be? 1 and 2. I said if I say and, it must be true for both things. So it must be A. That's how you got that one, eh? And not B. That's how you got that one. But I said it must be true for both. Is one part of A? It's not B, but it's not part of A. When I say A and not B, it must be in A. Those three are in A. But it must also be not B. So it can only be 2. If I had said A or not B, But if I say A and not B, it must be true for both. Okay. What's the probability of getting not A? Not A. Do you know which ones are not A? Everyone that's not in A circle. Not A and B. 2/6. Yeah, you've got it. What's the probability of getting A or not B? 2/6. A or not B. That one. What's the probability of getting C and D? If I say and, it must be true for both. C and D. 0. There's no numbers in C and D. What's the probability of getting C or D? 5/5. Right, are you getting the hang of it? Okay. So you must always remember and it must be true for both or just either one of the two. Then it's good. Okay. We're going to draw a Venn diagram. There are 420 learners in the school. 190 play soccer. 260 play cricket. 60 play both. We must draw a Venn diagram. Okay, tell me, how many circles must be in this Venn diagram? 3, 2, 3, 2, 2. Because it's soccer and it's cricket, no? Okay, must they cut each other? In other words, is this an inclusive event or must they not cut each other? Is it mutually exclusive? Inclusive. So there's soccer and there's cricket. Just quickly tell me, we didn't do the weather tree diagram yesterday, no? Will you remind me tomorrow? Because you're not going to have enough time now. Now, because they gave me the total number of learners, that 420, I always write the total right on the outside there. You won't get a mark for it, but you always do it, okay? Do you remember where we start with a Venn diagram? Where? In the middle. Which number can go in the middle? 60. 60. Okay. Now I have 260. I've now used the 420 and I've used the 60. I have 190 for soccer and 260 for cricket. What am I going to do with the 190 for soccer? Subtract what? Why? Because it's already in the circle, no? Okay, so I say 190 minus 60, it's 130. And what am I going to do with the 260? So there are 200 for cricket. Okay, now we have to check if everything is fine in there. What's 130 plus 60? 190 plus 200. 390. But there are 420 learners. There are learners who don't do either. It goes on the outside. You see, you can do this already without my help. It's not hard. Okay, I'm not going to get into the questions now of answering it. We will get there later on when we do the homework. I just want us to draw them at this stage. Okay. Next one. The probability that a person drinks milk is 0.6. The probability that he drinks water is 0.3. The probability that he doesn't drink either of them, So neither is 0,2. That's all the information that they're giving me. The question is, what's the probability that a person will drink both water or milk? Okay. Now, firstly, when they are referring to people that are drinking water and milk, I know that this is an inclusive event. So I've got one of two options. I can use the equation. The equation says the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. Now the problem is with that equation, I don't have the probability of OR, né? And I don't have the probability of AND. So I've got two unknowns, I can't use that. The second option that I have is to go and draw a Venn diagram. Okay, so let's do that. How many circles must they cut? Remember, they are asking you both, how many drinks both milk and water. So they are asking for and. Okay. Now there are two things that you must remember with this specific example. You must always remember it. When they give you a probability in a fraction format, so they're not giving you the number of people. Like with the previous one, they gave us the number of people. They didn't give the probability. If they give you the probability in a fraction, in a decimal fraction, or in a percentage, you have the total. What's the total of a percentage? 100%. So you would know when you add everything, it must give you 100. If you have a decimal fraction, what's the total of a decimal fraction? 1. So when I add all of it, it must give me 1. So remember, you have a total. If they give it a fraction, like they say, this is 2/5 and this is 1/5, then you know the total is going to be 5/5, which is also just 1. Do you remember where we start with a Venn diagram? Where? In the middle. What can I put in the middle? Do I know the AND value? That's what I want to calculate. No. So it's unknown to me. Do you know something that we use for an unknown in maths? Have you ever had an unknown? What do you write when it's unknown? So can we do that? Because it's unknown. There's nothing else that I can put in there. I can make that x. Now I just want to refer back to the previous Venn diagram. After you wrote that 60 there, you didn't take the 190 and write it there. You said 190 minus 60 to get 130. So tell me, what must I do with milk 0,6? 0,6 minus x. What must I do with water 0,3? Minus x. And what can I do with the 0,2? On the outside, no. Now just to prove to you that I'm not lying, going back to the previous one again, 130 plus 60 is 190, plus 200 is 390, plus 30 gave me the total. So if I add each part, it must give me the total. Now I have 3 unknowns, do you agree with me? But it's only one variable, and that means I can solve it. So I'm going to write 0,6 minus x plus 0,3 minus x plus 0,2 equal to 1. Zero comma 6 plus 0,3, 0,9 plus 0,2 is 1,1. So I'm going to take it to the other side. I've got 1 minus 1,1 equal to minus x plus x is just 0, but then there's 1 negative x left here. And then I've got negative x equal to negative 0,1 and therefore x is equal to 0,1. That's easy, ne? So now I've got the value for and. The probability of people drinking milk and water is 0,1. What's the probability for people drinking milk? What's the probability for people drinking water? There you have it. Okay, last example. Then you won't believe me, but you won't get homework. Okay, this is now about a hotel. There are 300 guests in total. 29 people did not eat. They are giving them breakfast, lunch and dinner. So you can choose whether you're going to eat by the hotel. So they are saying 153 had breakfast, 161 had lunch, 145 had supper, 95 had breakfast and lunch, 80 had lunch and supper, 52 had supper and not breakfast or lunch. 70 people had breakfast, lunch and supper. We are going to draw a Venn diagram. How many circles must my Venn diagram have? Must it intersect? Yes. I know 300 must be outside, no? Can I do something with the 29? Outside, no? So I've got that. Where do I start with the Venn diagram? Can I start with the Venn diagram in the middle? If I couldn't, I would still have to start in the middle. I would call it X. Okay. But I can start there. It's this last piece of information. Eh? So the 70 goes in the middle. Then I work from the bottom to the top. 52 had supper, but not breakfast and lunch. Where can I put that one? Oh, let me just name this. Breakfast, lunch, supper. 52 is in the supper one somewhere. Supper, not breakfast, not lunch. Where must that 52 go? Here or here? 1, 2 or 3? 2. Yeah. Because that part is breakfast and supper. This part is supper and lunch. This 52 is supper only. Okay, 80 had lunch and supper. So 80 is for this one. Can I write 80 there? No. 70 of the 80 are already in there. So what must I write there? You understand why? 95 at breakfast and lunch. Here's the gap for breakfast and lunch. What do I do with the 95? Subtract, so it's 25. Now I just have the big totals. Can I start with breakfast? I know that the total must be 153, but there are two gaps that are unknown, so I can't start there. I can go to lunch. Lunch is 161. How will I get the value of that one? We subtract those three from it, and then I get 56. I know that the total for supper is 145. Can I use it there? Huh? There's only one part of supper unknown. So I can say 145 minus 52 minus 10 minus 70. To write that one in there, it's 10. 13. I'm writing 13 but saying 10. Sorry. Okay, and then the last one is 153 for breakfast. Can I now calculate breakfast? Yes, because I found that 13. And then I just subtract them and I get 45. And there's my Venn diagram. Like a puzzle. No, but you must know where to start. And it must work out in all the angles. There are 3 minutes left. I think I quickly want to do the snow with you. No, you are tired. We'll do it tomorrow. But first thing tomorrow, the weather forecast. Okay, please remind me before you're going to start practicing Venn diagrams. I want to do that one. Because in the information they say 52 is supper and not breakfast or lunch. Okay, so this entire, let me draw it for you like this. This is breakfast, lunch, supper. Okay, but this part, this whole part here is breakfast and lunch, including that part. This part is lunch and supper, including that part, because there's also a lunch and supper. This part is breakfast and supper, but including that part, because this one also has breakfast and supper. This part is supper only. This is lunch only. This is breakfast only. So when they say 52, supper, not breakfast or lunch. That's how I know the 52 must go there, because this is supper only. But this one, they're just saying 153 at breakfast. So not just breakfast. That's the total that had breakfast. So that 153 is for this whole circle. Okay. The 161, that's for the whole circle. The 145 is for that whole circle. That 95 is for this whole intersection there. That's why I have to subtract the 7. Understand?
Không phải, không phải